Good morning. We are discussing IR spectroscopy and Hooke's law, which is presented by Prerna Chaukate, Aarti Chauhan, Vijay Chorghade, Dhakne Dhanraj, and Dhumar Shraddha, and guided by Aishwarya Balap ma'am. So first, introduction of IR spectroscopy. Infrared spectroscopy is one of the most common and widely used spectroscopic techniques, which is absorbing groups in the infrared region absorbed within a certain wavelength region. In this way, IR spectroscopy can be very sensitive to determination of functional groups within a sample, since different functional group absorb different particular frequency of IR radiation. Also, each molecule has a characteristic spectrum often referred to as the fingerprint. A molecule can be identified by comparing its absorption peak to a data bank of spectra. IR spectroscopy is very useful in the identification and structure analysis of a variety of substances, including both organic and inorganic compounds. IR region. Near infrared, poor in specific absorptions, consist of overtones and combination bands resulting from vibration in the mid-infrared region of the spectrum. Mid-infrared provides structural information for most organic molecules. Far infrared has been less investigated than the other two regions. However, it has been used with inorganic molecules. Then IR regions. There are near, middle, far, and most used regions. Then principle of IR spectroscopy. When the frequency of IR radiation is equal to the natural frequency of vibration, the molecule absorbs IR radiation and a peak is absorbed. Every bond or portion of a molecule or functional group requires different frequency for absorption. IR radiation does not have enough energy to induce electronic transition as seen with UV. For a molecule to absorb IR, it must be accompanied by a change in dipole moment. Principle of IR. There are two types, IR active and IR inactive. IR active, vibrational transition accompanied by change in dipole moment. Example OH, NH, C double bond O. And in IR inactive, vibrational transitions not accompanied by change in dipole moment. Example carbon-carbon single bond in symmetrical alkenes and alkynes. A stretch.